we are going to work on creating a contingency table, and then we're going to use that to calculate some conditional probability. Approximately 1 in 4,000 males are born with Fragile X syndrome. Prenatal genetic testing can detect Fragile X syndrome in the womb with an accuracy rate as high as 97%. Suppose 400,000 expecting mothers opt to have their unborn sons tested for Fragile X syndrome. We are going to use this information to fill out the table. So, what do we know? Well, we know that 1 in 4,000 have it, potentially, approximately, and then we have a 97% accuracy rate. So, if we are starting with 400,000 total, and we know that 1 in 4,000 have it, then how many out of 400,000 would? So we have ourselves a proportion here, right? So this is how we're figuring out how many would have the syndrome. If 1 in 4,000, how many out of 400,000? Well, if we're solving a proportion here, we'd have 4,000x equals 400,000. Divide both sides by 4,000, and we end up with x equals 100. So 100, we would expect 100 out of 400,000 to have Fragile X syndrome. Now, thinking through that, if 400,000 are the total and 100 have, then 399,900 do not. 399,900. Okay, so far so good. Now we think about accuracy rate. So, if you have whatever we're talking about, in this case we're talking about this syndrome, if you have it, we would expect to test positive. So that's where the accuracy rate goes. So 97% of 100 people that have it will test positive. That's 97. And that means 3 people will test negative, because if there's 100 that have it and 97 test positive, then 3 test negative. Okay. Similarly, if you do not have it, you would expect to test negative. So that's where that accuracy rate comes in. So 97% times 399,900, and we end up with 387,903 negative tests. Thinking through this, if 399,900 test or do not have it, and 387,903 test negative, then that means 11,997 test positive. Okay, let's sum up our columns, and we get 12,094 as well as 387,906. Perfect. Love this for us. Now we've created our contingency table. Now that I have those filled in, I can use this for some probability. So if someone tests positive, that means we have a conditional probability if someone tests positive. So we're putting positive tests on the bottom, because if, that tells us what's in the denominator. What is the probability the child does not have Fragile X? Okay, so we're only looking at positive tests. So let's just put a box around the positive tests. So that means our total is 12,094, and those that do not have it are 11,997. So now when I divide those, I end up with 0.99197 goes on. So I'm going to round that to 0.992, which makes this 99.2% of positive tests do not have it. Think about what that means. You test positive, meaning like you think that means that your unborn child has this syndrome, but 99.2% of positive tests actually do not have it. Is this a really accurate? I mean, it's accurate to 97%, but meh. So what is this called? This right here is called a false positive, because you tested positive, but it's wrong. And this is where a positive test would be kind of like, you probably would want to do it a couple of times to see, is it really positive, kind of a thing. Okay, so yeah, that's it.